The smallest planet in the solar system is Mercury. It measures only 4,1080 kilometers across, which makes it not much bigger than Earth's moon. In fact, two moons in our solar system, Ganymede around Jupiter and Titan around Saturn, are both larger in size than Mercury. This surprises many people because we usually imagine planets as always being bigger than moons. But Mercury shows us that size alone does not define what makes a world a planet. Mercury's mass is just 5.5% that of Earth. Its gravity is weaker, only about 38% of Earth's gravity, meaning if you weigh 100 kilograms on Earth, you would weigh just 38 kilograms on Mercury. Even though it is small, Mercury is unusually dense. Its iron-rich core makes up about 85% of its radius, one of the largest core-to-planet ratios in the solar system. This explains why, despite its tiny size, it still has a noticeable gravitational pull compared to what we might expect. Mercury orbits closer to the Sun than any other planet, at just 58 million kilometers away. This close orbit makes its year incredibly short, only 88 Earth days. From the surface, the Sun would look about 3 times larger in the sky than it does from Earth. And because Mercury has almost no atmosphere to protect it, the surface experiences extreme temperature changes. Daytime temperatures can climb above 400 degrees Celsius, hot enough to melt lead. At night, without any atmosphere to hold in the heat, temperatures drop to minus 170 degrees Celsius. This makes Mercury one of the most extreme environments in the solar system. When astronomers call Mercury the smallest planet, they are defining it by two measures, both size and mass. By diameter, Mercury is the smallest planet, just under 5,000 kilometers across. By mass, Mercury is also the smallest, far less massive than Mars, the next smallest planet. Dwarf planets such as Pluto and Ceres are smaller than Mercury, but they are not classified as true planets. According to the International Astronomical Union, a planet must orbit the Sun, be round due to its own gravity, and clear its orbital path of other debris. Mercury meets all three requirements, while Pluto and Ceres do not. Mercury has some unusual features. It has no moons, no rings, and only a very thin exosphere instead of a thick atmosphere. This exosphere is made of atoms like oxygen, sodium, and potassium, but it is so thin that it cannot support weather or climate. Its surface is heavily cratered, resembling Earth's moon, with large basins created by ancient impacts. One of the most famous is the Caloris Basin, a crater 1,550 kilometers wide, created by a massive collision billions of years ago. Despite its small size, Mercury even has a magnetic field, though it is much weaker than Earth's. This is unusual, because most small rocky bodies have lost their magnetic fields over time. Scientists believe Mercury became the smallest planet because of its formation history. In the early solar system, Mercury likely formed with more material, but much of it was stripped away. One theory suggests that giant impacts blasted away Mercury's outer layers, leaving behind the dense metal core we see today. Another theory proposes that Mercury simply formed from different building blocks, with more iron and fewer lighter materials. Either way, what remains is a world that is both small and heavy, unlike any other planet in the solar system. Beyond our solar system, astronomers have discovered very small planets orbiting other stars, known as exoplanets. One of the most remarkable is Kepler 37b, which is smaller than Mercury, measuring only about 3,900 kilometers in diameter. It is the smallest known exoplanet so far, even tinier than our own moon. Another example is Kepler 138d, which is similar in size to Mars. The TRAPPIST-1 system also contains several small, rocky planets, some smaller than Earth, all orbiting a cool red dwarf star. These discoveries prove that small planets are not rare, but are actually common across the galaxy. Studying Mercury and other small planets helps scientists understand how planets form and evolve. Small planets may not be habitable, but they offer clues about the early conditions of planetary systems. By comparing Mercury to exoplanets, researchers can see whether similar processes happen around other stars. Mercury tells us what happens when a planet forms close to a star. It loses its lighter materials, experiences violent impacts, and ends up with a dense metallic body. This gives astronomers a natural laboratory for studying planetary evolution. Mercury is not a place for life. Its surface is too hot during the day and too cold at night. Its thin exosphere cannot protect against radiation or hold onto water. But while Mercury itself is not habitable, the study of small planets may help us find habitable worlds elsewhere. By learning how small planets retain or lose atmospheres, we can apply that knowledge to exoplanets and ask whether any might sustain life. To put Mercury in perspective, let's compare its size to the other planets. Mars, the next smallest, is about 6,800 kilometers across, far larger than Mercury. Venus and Earth are both over 12,000 kilometers in diameter. Jupiter, the largest planet, is 142,000 kilometers wide, almost 30 times bigger than Mercury. So when we say Mercury is the smallest planet, we really mean it is tiny compared to the giants of the solar system. Even though it is small, Mercury plays an important role in astronomy. Its surface preserves a record of ancient impacts. Its dense composition raises questions about how planets form near their stars. Its orbit and interaction with the Sun's gravity help test theories of general relativity. And its comparison to exoplanets shows us that Mercury is not unusual, but part of a much bigger picture of planetary diversity. Mercury reminds us that small does not mean unimportant. It is the smallest planet, but it has big lessons to teach us about the solar system and beyond. From its dense iron core to its cratered surface, from its harsh temperatures to its connection with tiny exoplanets, Mercury helps us understand how planets form, how they evolve, and how diverse they can be.